So the Roman numeral 4 section is on energy. This is where chapter 11 starts. And we begin with the definition for energy. It's the ability to produce a change in itself or in its surroundings. So you want to think about something moving, and it can either have the potential to change its position or to knock something over, or it can actually perform those tasks while it's moving. And your focus question, the second one, is actually answered next. There are two types of energy. Potential is stored in an object, and then anytime an object moves, it has kinetic energy. And we're going to look at each of those in detail today. So you'll see on the next part of your notes that there are actually 6 types of potential energy. The gravitational one is listed first, and that's the only one that we're going to actually do in any sort of detail. It's the only one we'll have with a formula for this chapter. Am I still writing? So for potential energy, I'm going to abbreviate it PE because I think that makes more sense. If you take a different type of physics class in college or next year, if you do AP, you might see it abbreviated as a U. But again, I'm going to do PE because that makes more sense for potential energy. And the gravitational kind is listed first. I put the page numbers in your book if you need to go back and read anything. So when you lift an object, you do work against gravity. All of that work that you have done to lift your object is now stored as gravitational potential energy in the object itself. That means when you let go, it has the potential for some sort of movement. So going back to the definition, it would affect itself, bless you, as it's falling because it's changing its position, and then it could affect its surroundings if it crashes into something. So anytime you do work against something, you've given it a type of potential energy. So in this case, when we lift an object, you do work against gravity, and now it has gravitational potential energy. And to get our formula, it's going to come from the work that you're doing. So when you lift something, what's the force that you're lifting?
Gravity.
Yep, gravity. Okay. So that's going to be the weight of our object. Okay. So the weight is, you're working against gravity. And specifically because we're lifting, it's a vertical displacement. So what we did was just substitute in. When you are lifting against gravity for your force, that's the weight of your object. And so weight is mass times gravity. And then for vertical displacement, it's just easier to call it a height. And so if we put those together, that's going to give us the formula for potential energy. So the mg comes from the weight of the object, which is the force you did as you were lifting. And then h is the height, which would be your vertical displacement. And do you remember the units for work?
Joules.
Good, joules. So since the potential energy comes from the work that you did, it also has joules for its unit.
Is it mass times gravity times height?
Yep, so it's mass times gravity times height. And you must specify a reference point. And we'll practice with this a little bit later, but I'm just going to draw a little picture down here. So you remember when we did the number line up on the board, we had 0, and then to the right was positive and to the left was negative? It's going to be kind of the same thing, except now instead of to the right and to the left, we're going to go above and below. So if I said that the floor that we're on right now is our reference point, anything above the floor is going to be positive, and anything below this floor would be negative. So if you were to walk down the steps, you would have negative potential energy.
Wait, so potential energy and mass, gravity, height, those are both measured in joules? Or
Once you multiply the mass, gravity, height together, it turns into joules.
okay. So potential energy is also joules?
Yes.
Okay.
And then on your reference point, so it's okay to have a negative potential energy. So in our case, if the floor was where I wanted the reference point to be and I said that's 0, if you were going downstairs, anything below that, you would have a negative potential energy. And then if you were able to jump at all or raise above the floor that we're on right now, that would be positive. So positive and negative. It's okay to have either one for potential energy. Do you have questions about that? For the other ones, you don't have to write what's in green. Okay, they're just examples. But what you will have to be able to know is to recognize examples of the other 6 types of potential energy. So you will need to know the words magnetic, electric, elastic, chemical, and nuclear. So for example, we've used this before. If I do work against this little thing that levitates, I have to do work to put it in the right position. Now it has magnetic potential energy stored in it because it's floating. So that would be an example of the magnetic kind. For the electric kind, that would be static electricity. So if you shuffle your feet on the carpet, you're doing work against friction to shuffle your feet, and that energy is being stored in you. It can be released when you touch something metal, and that's the shock that you feel. So the energy would be stored in you until you get that shock. Anytime you stretch an object, so like on your catapults, if you're doing work against an elastic substance to stretch something, it now, all that work you did is stored in the object so that when you let go, it now has the potential to fling away or to move. And then for the chemical kind, one example would be gasoline. Another one would be food. Anything that can undergo a chemical reaction to be used for movement would be stored as chemical potential energy. And then for nuclear, it's kind of the same thing, except now instead of the electrons interacting with each other for your reaction, it's the nucleons part of the atom. And that would be nuclear potential energy. You would see that in any kind of stars like the sun, or in power plants, bombs, anything like that. So on your test, you just need to be able to recognize the types. So magnetic, electric, elastic, chemical, and nuclear. And then our next part, kinetic energy is a lot shorter. Okay, there were 6 kinds of potential. There's only 1 kinetic. And just like the other type of energy, it's going to have units of joules as well. So work, potential, and kinetic energy, all your energies, they all have joules. Do you think kinetic energy can be negative? We're going to go with no. Okay. And we'll break that into steps. The 1/2 part doesn't matter. Can mass ever be negative? No, so you cannot have negative mass. The V stands for velocity. Can velocity be negative? It's a vector. Yes. Okay. So you could have negative velocity, but look, see how it's squared? What happens when you square a negative number? It's positive. Okay, so even if you could have a negative velocity, you're going to square it in the formula. It's going to turn out positive. So kinetic energy can only be positive. That makes a good multiple choice question for your test. So potential can be positive or negative. Kinetic can only be positive. And then they have the same units.
Wait, did you say potential can be negative?
Yes.
Okay.
Okay. So potential can be either one, but kinetic can only be positive.
So what does negative energy look like? Like, how does that work?
It's just in relation to a location.
Okay.
It's only by your position.
So
it's
it can
not
either
like
backwards or forwards.
right. It's the same thing. But instead of like backwards and forwards, it's just up and down. Okay, but it's the same idea. Any other questions? We're going to versions